gentlemen, good day pre-algebra. We are going over the rest of CO14, where we first practice plugging in values in for variables and solving, practicing order of operations. Just we got some work with negative signs, things like that. Just practicing working with variables and plugging things in. And today we're going to kind of get some graphing, which is another way to represent data. A lot of algebra is going to be graphing stuff, representing data on the coordinate plane, whether it be an equation or a chart, transferred scatter plots, or whatever. But we're going to kind of do what we did up at the top, only then put it on the coordinate plane. So it says, write each situation as an expression, evaluate it for the given values, and then graph it. You want to save up to buy an iPhone and decide to put $3 each day into savings. Will you be saving for a while? To buy an iPhone at $3 a day, will you be saving for a while? Yeah, that's why you should just buy a flip phone. How much will you have saved on day 5? How about day 8? How about day 12? So for starters here, we want to come up with an expression that's going to represent the total amount saved. Okay, at $3 per day, how would you calculate how much you have saved total on day 5, day 8, day 12? What would you do? Zoe? Exactly, right? To figure out how much you've saved on day 5, if you're putting away $3 per day after 5 days, that'd be 3 times 5, you got $15 saved. What would you do to figure out on day 8? Tristan? 24, 3 times 8. What did you do on day 12? Mia? 3 times 12, right? So basically what we're doing is we're taking $3 times whatever day we are on, 5, 8, 12, whatever. So our expression, our total saved, is going to be 3 times d, right? Where whichever number of the day we're on, here was 5, we took 3 times 5. Here was 8, we took 3 times 8. Here was 12, we took 3 times 12. That's going to give us a total amount saved. Okay? Everyone see where I got that? That's kind of the key to this, is coming up with that expression that represents the total amount saved. At $3 per day, whatever number of the day that we're on, we're multiplying that day by 3, because we're saving $3 per day, right? So let's kind of make a chart here using the values that we have, 5, 8, 12. Right? On day 5, how much did you say that we saved? 15. And we got that from taking 3 times 5, right? 3 times the number of the day. Day 8, we've saved 24, right? 8 times 3. Okay, and then day 12, anybody? 36, right? 3 times 12. Okay, so using the expression 3D, we're taking 3 times the number of the day to get the total amount saved. Okay, and so when we go to graph this now, I've left this coordinate plane blank, which means we're going to have to fill in our labels ourselves here. What would be a smart way to label our x-axis, the one that's going across? If you need to label it, go ahead, right? The one going horizontal is x, and our y-axis, the one going vertical, is the y-axis. What would be a good way to label these so that when we look at this graph, we know what we're talking about? First, let's get some labels for the axes, right? Should we put our day on the bottom or our day up the top? What do you think? You've done graphing before, yes? I should have asked that. It was on your, at least plotting points, right? It was on the entrance exam, okay? Plotting points, generally did pretty well with that. What goes along the x-axis is typically kind of like your independent variable. It's what you're testing, okay? So we are going to label our x-axis as the day, okay? The number of the day is what's going to go along the x-axis, because how much we've saved depends on the day. So our y-axis here, I'm trying to write sideways, is amount saved, right? That's going to be going up the y-axis there, the amount saved. Now let's put some numbers on this thing. How should we count along our x-axis? Should count by ones. Would that be a very good idea? Anthony?
Threes?
Why by threes?
Because like they all could be a three.
Okay, we know that we're going up by 3 every single day, right? Why wouldn't we want to count by ones? Let's answer that question first. Why would counting by ones be a poor decision here? Yeah. Takes you long, and
We wouldn't like have room, or it would be like messy.
it would be kind of messy. And maybe, if depending on how far out we want to take this thing, I think there's only like 20 increments, 20 boxes going across the bottom. Once we get to day 20, then we'd be done. We wouldn't have any more space to go. So since we're counting by threes up the well, actually, Anthony, I think you kind of got me in my mind backwards. I think our money saved should be counted by threes because that's going up by threes.
That's what it is.
Oh, okay. I was talking about the x-axis. We confused each other, I think. Yeah. If we went along the x-axis, yes. Okay, let's back up. I wish I knew how to edit these videos so we could go back and eliminate the things I said. Talking about the x-axis, the number of days, we would want to count by ones there because that's increasing by 1. Okay. The y-axis, we want to count by threes because that's increasing by threes. And if we counted by ones, on day 12, we're already up at 36. We'd run out of spaces. Okay. So let's count our x-axis by ones. You might have to kind of squeeze your values in there to make them fit. Or if you want to write every other, to give yourself a little more space, and you'll just have to know that what's in between your even numbers are the odd numbers. You can do either way. You can write each individual number out like I started to do, or you can skip, right? And then so it's not quite so scrunched. And then you'll have to know that in between 14 and 16 is the number 15, right? Then going up the y-axis, we do want to count by threes here because the money saved is increasing by threes. So we'll go 3, 6, 9, 12, 15, 18, 21, 24, and so on. If you do your calculation correctly, you should end at 60 all the way up at the top. End at 60 all the way at the top. Okay. And let's go ahead and plot these points, right? The nice thing about making a function table here is that it gives you ordered pairs. Day 5, we've saved $15. That's the ordered pair 5, 15. So when we look at our coordinate plane, we go to day number 5. We go to our y value of 15. And that dot represents the information that on day 5, we've saved $15. Okay, if you played Battleship before, it's very similar to that, how you plot these points, kind of line them up, see where they intersect there. On day 8, we've saved $24. So now we're going to go over to 8 on our day, up to 24 on our money saved. And there we have it. And then 12:36, similar process. We're going to go over to day 12 on our x-axis, up to 36 on our y-axis, and there's our point there. Okay? Now, what's the point of graphing stuff? Why put this on a coordinate plane like this? What does it allow us to do? It's more visual, for one. Here's the expression, the equation that we just graphed on here. Numbers, it kind of hard to visualize what's happening. We put it on a graph, we can see it better. We can also predict what's going to happen. You know, following this trajectory here, notice these points kind of make a line, right? We can use that line to predict how much money we'll have saved on day, say, 16. Well, day 16, let's follow up to our line. We're going to have $48, right? We didn't have to calculate that. We used the graph to find it, okay? On day 20, on day 20, if my line was straight, we'd have $60, okay? So the idea behind graphing and the point of graphing is to be able to visualize and see what's coming next, to predict things. Questions so far? Comments, concerns, complaints, compliments, congratulations, criticisms? Okay, on to the next one then. I think yours is okay. Some are, is it kind of cut off a little bit?
Yeah.
Ugh, bummer. Okay. Your parents give you and your sister points for each chore completed, and today, in the spirit of Christmas, they're going to double the total points earned. Oh yeah, the next one's cut off. No, it's not. That one's good. Okay. Total points earned. Before doubling, your sister earned 7 points. How many total points will the two of you have if you earn 3 points? Again, before doubling. How about 10 points? How about 15 points? So we're going to start here by, again, writing this expression for the total number of points earned. It says they are going to double the total points earned by you and your sister. Your sister's already earned 7. What expression is going to show doubling the sum of you and your sister's points? Penelope, what does the word double mean?
Like something twice.
Okay, and the word twice means, think back to our operations.
That's me.
What?
Is that to me?
Sure.
Well, twice is just like 2.
But what operation? Does twice mean you're adding to? Multiplying by 2, right? So something's being multiplied by 2 here, right? 2 times something. Now, what is being doubled? The points. How do you get the points? By doing the chores, okay? And when I say, how do we, like, is it just your points being doubled?
No, it's your sister's as well.
Your sister's as well. So your total points combined, right? How do you show, what operation would show combining your points with your sister's points?
Multiply by 2.
That's what we're going to do with the total, but to know what we're going to double, if we're doubling both you and your sister's points together, what operation is going to show that? We're going to add them, right? Do we know how many points that you've earned? Or is that what changes? It's what changes. That's the variable, right? So your points changes. So we have to put a variable in there. Your sister's points, she's earned 7. That's it. She's done. Tapped out. Right? So the expression is going to be whatever number of points you earn plus your sister's plus the 7, that being multiplied by 2. Okay? So let's go to our function table here. Let's get your points. I'm going to add a third. I'm not going to go quite that far. I want to leave room for my labels here. I'm going to add a third column. I'll put your points. I'm going to put the expression. And then I'm going to put the total. Okay? So 3 columns here this time in our function table. So if you earn 10 points, okay, your points is 10. The expression is going to be 2 times 10 plus 7, right? I've plugged in the 10 in for your points, your variable, in for P, so that we can find the total number of points earned after you add your sisters and your parents double. How many points do you have in all? How many points do you have in all? Is that hand up, Tristan? No? So we're adding 10 and 7, then doubling it. How many points is that? 34, right? 17 times 2. The total is 34. Okay? If you earn, we skipped 3. Thanks for telling me. If you earn 3 points, okay, the expression is going to be 2 times 3 plus 7. Nothing else changes, only the number of points that you've earned, 2 times 3 plus 7. And how many total points will that be? 20. 3 plus 7 is 10 times 2, 20. If you earn 15 points, the only thing in the expression that changes is the variable, right? That's why it's a variable. It's what changes. This time we're plugging in 15. And how many points will there be in all?
105.
Not 105. Try that. 46? Close. 44, right? 15 plus 7 is 22, times 2 is 44. It's hard to read because as the world was shaking for a second there, it's kind of got, okay? But again, what we've created here are 3 ordered pairs that we can plot. We've got the ordered pair of 10, 34, the ordered pair of 320, so they're kind of out of order, but that's going to fix itself when you put it on the coordinate plane, right? It'll be okay. And 1544. For tomorrow, the only thing I'd like you to do is to graph the information that we've had here, which means you need to label your axes like we did. Label the x-axis, label the y-axis, put in the numbers, be smart about it. I mean, don't count by ones on the y-axis because we're already up to 44 and you're going to run out of space. What should you be counting by? Okay? And then plot the points on there. Right? So label each axis with words, like we did. Label each axis with values, with numbers, like we did. And then plot the points. That's all you got to do for tomorrow. Do you think we can play the number game tomorrow?
I hope so.
I hope so too. Okay? If you need to get back in for the homework check, please do so. It'll open up later on today. And last night it was open till 8:30 because I did open it a little bit after 2. Shout out to the student who reminded me. Thank you for that. But that's how you math.
Don't forget to like and subscribe.
Thank